Think about the last time you heard someone talk about artificial intelligence. Usually, it feels like magic. It feels like something happening in a distant lab or a movie where robots take over the world. But the reality is much more grounded. Artificial intelligence is simply the science of creating machines capable of human-like cognitive functions. This includes learning, reasoning, and problem-solving. It is not about building a conscious being. It is about building tools that can handle tasks requiring intelligence. When we talk about the field today, we are mostly talking about narrow artificial intelligence. This is the kind that excels at specific tasks. It is not the theoretical general artificial intelligence that can do anything a human can do. We are seeing a massive shift from traditional systems that relied on programmed rules for precise analysis to modern systems that use probabilistic machine learning models. These models improve through data exposure rather than explicit programming. This distinction is crucial because it changes how you build things. You are not writing rules for every possible outcome. You are designing systems that can learn from examples. Now consider the practical application. Universities like Iowa State and Harvard illustrate this duality through practical applications. Artificial intelligence enhances productivity via tools like Copilot and Firefly. It improves healthcare diagnostics and boosts educational engagement through personalized tutors. However, there is a clear tension regarding integration. While some experts argue it revolutionizes sectors without diminishing human capability, others warn of an economic bubble and risks to job security. The primary knowledge gap lies in the long-term impact. Specifically, the consensus on how to balance rapid innovation with necessary oversight remains incomplete. So, how do we move from theory to practice? We start by designing an agent. An agent is different from a standard chatbot. A chatbot just talks. An agent acts. It has goals. It uses tools. The architecture relies on three main components. Perception is the first step. The system needs to understand the input. Reasoning follows. This is the core intelligence where decisions are made. Action completes the cycle. The system executes tasks based on those decisions. To build this, you do not need a supercomputer. Modern development relies heavily on open-source collaboration and community-driven repositories for sharing algorithms and datasets. You can use open-source tools to assemble these pieces. You start with a large language model. This serves as the reasoning engine. Then you connect it to specific functions. These functions might be code interpreters, search APIs, or file system access. When you combine these, you get a system that can write code, search the web, or organize files. Here is the thing about building an agent. It is not a one-time setup. It requires iterative development. You will not get it perfect on the first try. You need to test it against common engineering tasks. Does it understand the context correctly? Does it execute the commands safely? If it makes a mistake, you analyze the failure and adjust the logic. This is similar to how you would train a junior engineer. You give them a task, they try, they fail, they learn, and they try again. There is a growing emphasis on artificial intelligence as a tool for augmenting human capabilities rather than solely replacing human labor. This is the most important perspective to hold. You are building the agent to handle the repetitive parts of your workflow. This frees you to focus on the complex decisions that require human judgment. The future systems are predicted to become increasingly specialized and integrated into daily workflows. This requires continuous adaptation of ethical frameworks. You must consider the risks. When you deploy this system, you are creating a workflow. You define what the agent should achieve. You provide the constraints. You let it run. If it encounters a problem it cannot solve, it should ask for help. This human-in-the-loop approach ensures safety. It prevents the system from making irreversible mistakes. It keeps the human in the driver's seat while the machine handles the navigation. The extent to which artificial intelligence can truly replicate human creativity versus merely simulating it based on training data continues to be a subject of ongoing academic inquiry. But for practical purposes, the utility in automating repetitive tasks is undisputed. You can build a system that writes your unit tests. You can build a system that summarizes your meeting notes. You can build a system that monitors your servers. The tools available to you are vast. There are frameworks designed to help you chain these capabilities together. You write code that tells the model what it can do. You define the tools. You set the instructions. This is the architecture. It is modular. You can swap out the reasoning engine. You can swap out the tools. This flexibility is what makes it powerful. You are not locked into a single vendor. You are building on open standards. As you develop your own agent, remember that the technology is evolving rapidly. What works today might change tomorrow, but the principles remain the same. You define the problem, you design the solution, you test the system, you refine the process. This is the engineering mindset. It is not about magic, it is about logic and iteration. The ethical boundaries and future trajectory of its influence on society require further investigation. We must remain vigilant. We must ensure that our systems are transparent. We must ensure that they are fair. We must ensure that they serve the user. This is the responsibility that comes with building these tools. You are shaping how technology interacts with the world. In conclusion, building an artificial intelligence agent is a practical journey. It starts with understanding the difference between rule-based systems and probabilistic models. It moves through designing an architecture that perceives, reasons, and acts. It relies on open-source tools and iterative development to refine the performance. It focuses on augmentation rather than replacement. You are not building a replacement for yourself. You are building a partner that can handle the heavy lifting. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.